Today your lesson will be on adding probabilities. Recall that the last two lessons were on multiplying probabilities and conditional probability, which also involved multiplication. So today you're going to be learning all about adding probabilities and when we do that. To understand adding probabilities, we need to be reminded of when events are either mutually exclusive or mutually inclusive. So I want you to think, can a card be both a king and an ace at the same time? Can a card be a king and an ace at the same time? And that is no. Because we say no, we know that these are mutually exclusive. Can a card be both black and a 6 at the same time? Think about it. Black and 6. We actually can have a 6 of clubs and a 6 of spades. So there are actually two cards that can both be black and 6 at the same time. That makes it mutually inclusive. Remember that mutually exclusive basically means that they cannot be both at the same time. Mutually inclusive, meaning they can be both at the same time. So, how to find the probability when we have mutually exclusive events? For a probability of mutually exclusive events, we need to learn a new symbol. The symbol is going to be called union, and it looks like an uppercase U. This means that the probability of A union B really means probability of A or B. Recall that the probability of A intersection B means the probability of A, said that wrong, probability of A and B. So, and intersection or union. So, A and intersection or union. Intersection looks like that, and union looks like that. Sorry about that. All right, so remember to read it as the probability of A union B as we read it. So when we want to find the probability of this or that occurring, we are finding a union and we are going to add probabilities. So that key word you need to think or, add, and multiply. So I'll put up here, multiply when you see and add when you see or. So our addition rule, number 1, states that the probability of A union B is equal to the probability of A plus the probability of B. So let's take a look at the first example. It says a single 6-sided die is rolled. What is the probability of rolling a 2 or a 5? So one thing to note is the word or. As soon as I read that, I know that I need to add probabilities. So if I'm trying to determine if I roll one die, what is the probability of rolling a 2 or a 5, I need to first understand the probability of rolling a 2. The probability of rolling a 2 would be 1 out of 6, while the probability of rolling a 5 would be also 1 out of 6. Because we see the or, we know that we are going to add. So I'm going to write this as the probability of rolling a 2 or a 5, so probability of 2 union 5, is equal to the sum of their probabilities. So probability of rolling a 2 plus the probability of rolling a 5. So that's kind of substituting it right there into our addition rule. Since the probability of rolling a 2 is 1 over 6, and the probability of rolling a 5 is 1 out of 6, I simply add these together to get 2 out of 6. Remembering that when you add fractions, you only add the numerators the denominator stays the same. That also means we need common denominators. B. A spinner has 4 equal sections colored red, yellow, blue, and green. So I'm going to draw a little diagram here of a spinner that has red, yellow, blue, and green. From looking at this, since they are equal sections, we know the probability of landing on either of these would be 1/4. Since we are asked what is the probability of landing on red or blue, so probability of red union blue, remember that that's the probability of red plus the probability of blue. Since my probability of red is 1/4 and my probability of blue is 1/4, again I add my numerators here and my probability is 2/4. So I wanted to read C, and then I would like for you to total up how many marbles are in there, press pause, and answer the problem. A glass jar contains 1 red, 3 green, 2 blue, and 4 yellow marbles. If a single marble is chosen at random from the jar, what is the probability that it is yellow or green? Hit pause at this point. Since there are 1 red, 3 green, 2 blue, and 4 yellow marbles, we know that there are a total of 10 marbles. 10 marbles altogether. We can actually find that the probability of red is going to be 1 out of 10. The probability of green is going to be 3 out of 10. The probability of picking a blue is 2 out of 10, while the probability of picking a yellow will be 4 out of 10. And that's just from understanding how many there are of each color out of the total. But we are asked, what is the probability that it is yellow or green? Since we want to find the probability that it is yellow or green, we add the probability of picking a yellow with the probability of picking a green. Since the probability of picking a green, or yellow's first, is 4 out of 10, I write that, and then the probability of green is 3 out of 10. I find the sum of my numerators, so 4 and 3 add up to 7. So the probability of picking a yellow or a green marble is 7 out of 10. Next, I want you to try part D after I read it. D says, a single card is chosen at random from a standard deck of 52 cards. What is the probability of choosing a jack or a 10? We first need to understand how many jacks and 10s there are. The probability of picking a jack would be 4 out of 52 because there is a jack in each suit, a jack of spades, clubs, diamonds, and hearts. Likewise, there are 4 10s in the deck. A 10 of hearts, 10 of diamonds, 10 of clubs, and 10 of spades. So that's the background information we need to understand to be able to answer the question. So what is the probability of choosing a jack or a 10? So I know I need to add here. So the probability of picking a jack or a 10, again, will be equal to the probability of picking a jack plus the probability of picking a 10, or 4 out of 52 plus 4 out of 52, giving us 8 out of 52. So that was finding the probability of mutually exclusive events, meaning a jack cannot be a 10. A yellow marble cannot be a green marble. On our spinner, you could not land on a section that was both red and yellow at the same time, or red and blue at the same time. And the same as if you roll a die, you can't land on a 2 or a 5 at the same time. So those are mutually exclusive. What you're going to learn now is how to find probability if our event is mutually inclusive. Recall that mutually inclusive events can occur at the same time. For example, a student can be both a math and art student simultaneously. So now we need to learn addition rule 2. If we have two events, A and B, and they are inclusive, then the probability of A union B is equal to the probability of A plus the probability of B minus the probability of A and B. So this right here, notice we're going to add just like we did prior, but we have to subtract what they have in common. Subtract what they have in common. So let's consider this Venn diagram in the PowerPoint. Notice if you have two events, A and B, and they have a section that overlaps. It's hard to see on the PowerPoint, but if you look at the slide, you'll see it. The section that's kind of purple there in the center is what they have in common. So if we want to find the probability of A or B, we must subtract their intersection, so we're not counting it twice. That section that's purple is already counted when we find the probability of A, and the purple section is also counted when we find the probability of B. So if we don't subtract it, we are including that overlapping area twice. So let's apply this addition rule. If we want to find the probability of getting a king or heart, we first should know the probability of each. So the probability of getting a king, remember there are 4 kings out of 52. The probability of a heart being drawn would be 13 out of 52. Actually, let me put it up here. Probability of heart equals 13 out of 52. What we need to think is, are there any hearts that are kings or kings that are hearts? Yes, we actually have a king of hearts. So this king of hearts is counted in with the kings, and it is also counted in here with the hearts. To find the probability of a king or heart, we apply the addition rule number 2, remembering that the probability of A or B for a mutually inclusive event is the probability of A plus the probability of B minus the probability of A and B. Oops, let me slide this over. Sorry about that. So we can transfer what we understand here into kind of this formula here. So probability of a king plus the probability of a heart minus the probability of the king of hearts, basically. So the probability of a king was 4 out of 52. The probability of a heart was 4 out of 52. But we have to subtract the king of hearts, 1 out of 52. 4 plus 4 is 8, minus 1 is 7. So the probability would be 7 out of 52. Next, that's for A. Next, we want to consider an ace or a red. Remember that the probability of an ace is 4 out of 52. The probability that a card is red is half the deck, so 26 out of 52. Do we have any red aces? Yes, we actually have an ace of hearts, that is red, and an ace of diamonds. So we're going to need to subtract these two because they are counted in the aces and they're counted here with the reds. I'm going to stop at this point so that you can go ahead and try this one on your own.